So today we will look at an important graph algorithm, that is the Floyd-Warshall algorithm, which is an algorithm to solve this problem, which is the all pairs shortest path problem. That is shortest distance between all vertex pairs. So this is a vertex pair 1 and 4 and we want to find the shortest path between them. This is a path pair 0 and 2, 1 and 5 is a pair, 0 and 4 is a pair, 3 and 2 is a pair. All these are pairs and we want to find the shortest distance between these pairs. Shortest distance means we want to reach from here to here along some path, and that the whole distance it should be shortest. So let us say this was our example graph. So let us say we are given a graph. So this is our graph and this is the graph matrix representation form, in matrix representation form. So we create a shortest distance matrix which is same as the graph matrix, but here -1 represented that there is no edge. Here we represented by infinity. So I've written infinity here. While coding, you take a sufficiently large number like 999999, or if you are using suppose you are writing in C, so there is a library in C called #include limits.h. In that there are two variables defined, max value and min value. I don't remember the exact names of those variables, but I think those names are max value and min value. So you can directly use these names if you have already included this library. They come predefined in this library, so you can use them. Or I think this name is limit.h. So we are just talking about the algorithm here. So for each pair, then what we do is so this is the initialization of the short matrix, which represents the shortest distance between two vertices. So k is not an intermediate vertex. There are two cases for each pair of vertices I and j. So let us say we are considering this pair of vertices, this one and this one. So maybe vertex number, this is 0 1 0 1 2, so this is 1 and 2. okay, so k is not an intermediate vertex in shortest path from I to j. So if k is not an intermediate vertex, this is one case. So then we keep dist ij as it is. If k is an intermediate vertex in shortest path from I to j, we use this formula. Dist ij is equal to dist ik plus dist kj. That is, let's say this is our ith vertex and this is our jth vertex, and here somewhere lies our kth vertex. So let us say we are considering the shortest path, and this is our shortest path, and we are not having this k vertex in between. So our distance between these remains same, but let's say this also lies in between. Then the distance from I to k plus distance from k to j, if it is smaller than the dist ij, then we update dist ij as dist ik plus dist kj. So we just check. So dist ij value is something initially. So what we do is we just check the value of dist ik plus dist kj. So if this value, what this represents, we are going from I to k and then k to j. So finally we are starting from I and finally we are reaching j. So we are going from I to j via k. Okay, yeah, through k, that is via k. So if the distance from I to j via k is even less than our distance ij value which we have, then we update this. If it is less than dist ij, then we update our dist ij to be equal to this new value. So previously we were not considering the path which goes via k, so we were using some another path, but the path which goes via k is smaller. So let's say this is the thing. So let's say here are two vertices, here k is located and here some t is located via I and j. So earlier our dist ij was having this value, this path plus this path, and we were not considering k as an intermediate vertex. But if we consider k as an intermediate vertex, so the distance from I to k plus distance from k to j is smaller than this distance earlier, dist ij. So that is a better option. So we update dist ij to be equal to dist ik plus dist kj. So this is the main concept of this algorithm, and this 2 lines finishes this algorithm actually. So, and this is considering of these two cases is exhaustive, because either k will be an intermediate vertex or k will not be an intermediate vertex. There are only 2 possible cases. There is no third case. So I hope, and this is actually dynamic programming. So I hope this is clear. Thank you, friends.